So here we are. We made it to the end of this chapter. So what are we going to go for on this section C? We're going to be talking about now about isotopes. So isotopes are going to be a new concept. And we're going to see how to write an isotopic symbol once we understand what the mass number is, and we already know how to determine the atomic number. Atomic number is straight from the periodic table, right? And that gives you the number of protons. So what is an isotope? So let's see. Imagine a situation like this. And the question is, are these three models representative of an isotope? Well, I'm going to answer that question, and then you're going to tell me if you understand what an isotope is. So this element, the one on my left side, 1, 2, 3, 4, 5 protons. So I know this is going to be boron. So we got 5 protons, which means atomic number 5, which means from the periodic table, boron. What about the next one? 1, 2, 3, 4, 5. That's also going to be boron. And the last one, 1, 2, 3, 4, 5. 5 protons, so atomic number 5, so that's also boron. What about the electrons? Are these ions? 5 protons, 1, 2, 3, 4, 5. 5 electrons. So these are not ions. This one is not an ion, so there's no charge. 1, 2, 3, 4, 5. Same story there, not a charge. 1, 2, 3, 4, 5. Same story there. 5 protons, 5 electrons, so no charge. So these are not ions. So are they different? Let's see. I counted the protons, I counted the electrons. Now let's count everything else. So let's clear the screen. So the only thing we have left to count is the neutrons. So this one have 5 protons, 5 protons, and 5 protons. Neutrons, 1, 2, 3, 4, and 5. 5 neutrons. 1, 2, 3, 4, 5, 6. 6 neutrons. 1, 2, 3, 4, 5, 6, 7. 7 neutrons. And with that, you should be able to tell me, oh, I know what that isotope is. An isotope is nothing more than the same element with a different amount of neutrons. To be the same element, the protons have to be the same, right? Atomic number. So that's what an isotope is. It's the same element with a different amount of neutrons. And why is that? Well, remember, the function of the neutron, on a very simplified way, is to hold all the protons together, prevent them from repelling each other. They're repelling each other, but the neutron is holding them in there together. Nature decided that sometimes it can do that with 5 neutrons, sometimes it needed 6 neutrons, and sometimes it needed 7 neutrons on this case. So when the elements are forming, and they form on the stars, and you can look at the tutorial videos and a video that tells you how the elements were formed. When they are formed from the extreme pressure of the supernova, sometimes they capture this many protons, this many neutrons, so sometimes they capture this many neutrons during the creation. And even though the element have the same number of protons, making it the same element, the neutrons are different. So that's what the isotope is. When the number of element is different from when the number of neutrons, is different on the same element, on the same atom with the same number of protons. So how can we represent this? What we're gonna do, we're gonna create an isotopic symbol. The element is boron. We know it's boron because it has 5 protons. So we know I have 5 protons. So the element is boron, and we have 5 protons, and the element is boron, and we have 5 protons. And then this one is going to be 10, this one is going to be 11, and this one is going to be 12. See if you can figure out where the 10, 11, and 12 are coming from. Give you about 3 seconds to try to figure that out. Where is the 10, 11, and 12 are coming from? Remember, 5 protons and 5 protons, right? Did you see it? I hope you did. 5 plus 7, 12. 5 plus 6, 11. 5 plus 5, 10. So, and this is the way it goes. X is going to be the symbol letter, in this case B. Z is going to be the number of protons, and A is going to be the number of protons plus neutrons. So A is number of protons plus the number of neutrons. Both of them together, we call this the mass number. So for you to be able to know the mass number, you need to know the number of protons, you need to be given the number of neutrons. So this is how we create an isotopic symbol. So what is an isotopic symbol? That's an isotopic symbol, where you have the element, the atomic number, which is the same as the number of protons, right? And the mass number, which is the same as the number of protons plus the number of neutrons. So now we have a better way to more precisely describe an atom. With this symbol, I can tell you how many protons, I can tell you how many neutrons, and I can tell you, based on the number of protons, the number of electrons. And if it happens to have a charge, you can still tell me the number of electrons like we did before. So let's practice this. Determine the atomic number and the mass number. So atomic number is the number of protons, and we find it on the periodic table. The mass number is the number of protons, right? Plus the number of neutrons. So for the first one, hydrogen. When I find hydrogen, and let's do it like this. So we're gonna do the symbol. We're gonna do the number of protons, and we're gonna do the number of neutrons. And remember, the number of protons are positive, right? So hydrogen is gonna be, according to the periodic table, hydrogen, H, right? And it's gonna be atomic number 1, so that many protons. Or actually, what we're doing on this exercise, not the number of protons, we're doing the atomic number. So straight from the periodic table. And how many neutrons? Well, it's telling us that we have 2 neutrons, right? And we have 1 proton. So altogether is 3. So it's not looking for the number of neutrons, it's giving us that. What it's looking for is the mass number, which is proton plus neutrons. What about the second one? Second one is chromium. I do not know chromium from memory, so let's go find it. So chromium is gonna be right there. Atomic number 24. So atomic number 24. So that's gonna be that. Symbol is chromium, and that's gonna be 24 protons plus 28 neutrons, so the mass number is 52. What about the next one? Calcium. Calcium is atomic number 21, which means it's going to have 28 protons plus 22 neutrons, so the mass number is 43. And the last one, tantalum. I definitely don't know that one from memory. Tantalum, let's find it. This probably is going to take me a little bit longer because I'm not used to this one. So I saw it right away, lucky day. 73, tantalum. Tantalum is going to be 73. So tantalum is atomic number 73, which means it has 73 protons plus 109 neutrons, which altogether is going to be 182 for the mass number. So the mass number on the first for tantalum is 182, for calcium is 43, for chromium is 52, and for hydrogen is 3. And we got that by using the periodic table and the number of neutron givens, and knowing that the mass number equals the number of protons plus the number of neutrons. And the number of protons comes from the atomic number, which is the same from the periodic table. What about something like this? Write the isotopic symbol. So we're going to write something like that for each element. Remember that X is the symbol from the periodic table. A is going to be the mass number, which is proton plus neutrons. And C is the atomic number straight from the periodic table. So oxygen, symbol oxygen. Fluorine, symbol F. Sodium, symbol sodium, Na. And aluminum, Al. And I know those from memory because I have done this so many times. It will happen to you soon, very soon. Oxygen, so at the bottom we're going to put the atomic number. 8 from the periodic table, 9, 11, and 13. 8 neutrons, 8 protons plus 8 neutrons, 16. 10 neutrons, 10 neutrons plus 9 protons, 19. 12 neutrons, 12 neutrons plus 11 protons, 23. 14 neutrons, 14 neutrons plus 13 protons, 27. And that's how we write the isotopic symbol for any element given the name and the neutrons. What would be an isotope of oxygen? Well, we know that we have oxygen 16, so an isotope of that would be oxygen 18 could be one, right? Because the element is still the same, therefore the atomic number is the same, but the number of protons plus neutrons is changing, so the neutrons are different. Another thing you need to know, there's another way to write an isotopic symbol. Instead of saying 19/9F, you can say fluorine 19. You can say sodium 23. You can even say sodium 23, where you put in the symbol with the mass number, the symbol with the mass number, or the name with the mass number. And so you can do aluminum 27. So you can capture all that information in so many different ways there. Well, the standard isotopic symbol is the one that looks like this, with the atomic number at the bottom left, the mass number at the top left, and the symbol to the right. So with that said, go ahead and do that. I just want to know, based on that symbol, can you word this backwards? Based on that symbol, can you tell me which one, how many protons on phosphorus 33, How many neutrons on phosphorus 33? And the other three. And then you can do what we just did. And you can do also what I showed you, this format also. And with that, we have covered how to determine the atomic number given the isotopic symbol. So basically, if I gave you this isotopic symbol, you can say that the atomic number is 13, the mass number is 27, therefore 13 plus something equals 27. 13 is the number of protons, this will be the number of neutrons, so you got 14 neutrons. You should be able to do that with an isotopic symbol given. Determine the number of protons and neutrons from isotopic symbol. We just did that, but let's practice some more. So if I have this, where I have sodium 11 and 23, the atomic number is the same as the number of protons. So you get that already. And the mass number, which is 23, equals the number of protons plus the number of neutrons. Since you already know the number of protons, you can find out how much that is. So the number of neutrons, on this case, is going to be 12 neutrons. 12 plus 11 equals 23. And you do the same thing with that one before. So we did that already. And then you can do that again. And with that, we just covered that. So we got only one more thing to go. So now that you know what isotopes are, and you know about the mass number, can you calculate the atomic mass based on percent or natural abundance? And this is like this. Consider that you have a block of aluminum. So this is made out of aluminum. And if we take a microscopic view of that, you're going to have aluminum. So you're going to have a bunch of aluminum atoms in there. It's a pure substance, right? And if we take a look at this atom, this could be aluminum 27, while this could be aluminum 26, right? So if we consider that it's even all over the block of aluminum, so let's say my aluminum 23 is going to be 1, 2, 3, 4, 5, and 6. My aluminum 26 is going to be 1, 2, 3, 4, 5, and 6. And then I have another aluminum, another isotope, which is going to say, I'm just going to say it's 28, right? So this one is going to be 1, 2, 3, and 4. So that chunk of aluminum follows that pattern. So altogether we have 1, 2, 3, 4, 5, 6, 7, 8, 12. So we got 15 atoms. The aluminum 27, we have 6 out of 15. The aluminum 26, we have 6 out of 15. And the aluminum 28, we got 4 out of 15. So the percentage of each one is different. So on this planet, Since the planet was created, all the elements kind of have a same distribution. So based on that, whatever piece of aluminum I take on this planet, and this is just we're making this up, you can count that you're gonna have 6 out of 15 of aluminum 27, 6 out of 15 based on percentage, right, of aluminum 26, and 4 out of 15 of aluminum 28. So that's what we call the relative natural abundance. So when we go to the periodic table, so let me show you something here, right? When you go to the periodic table, you're gonna notice that it shows you the symbol, it shows you the atomic number, and it shows you something else. It shows you this number there. That's what we call the atomic weight. So the atomic weight is gonna be based on how much of every isotope you have. For example, let's look at palladium. When you put all the isotopes of palladium together that you find on any sample on this planet, they're gonna give you this number. So this is gonna be their average number. So let me show you how we're gonna do that. The way we're gonna do that is gonna be by considering the percentage that you have of each one and working on that. So let's do a problem here. So let's start with this here. These are isotopes of which element? We have been doing that before. 5, 5. This is boron. So we have done that. So there's not much that we need to do here. But look at this problem. So this is what you see on the periodic table. And I told you that this number is an average of all the different isotopes. So this is where this comes from. So they took a sample of silicon to the lab and they determined that there was 3 isotopes. One of them was silicon 28, the other was silicon 29, and the other one was silicon 30. The percentage of silicon 28 was 92.21 percentage. That was silicon 28. Silicon 29, the percentage was 4.69%. So you barely find any silicon 29 on a sample of silicon. Silicon 30, the percentage was 3.10%. So in nature, when you take a sample of silicon, most of the atoms that make up silicons are going to be silicon 28. And then you're going to have a little bit of silicon 29 and silicon 30. So how do we get to this number then? Well, silicon 28, it doesn't weigh exactly 28. That's an approximation because the proton doesn't really weigh 1.0000. It probably weighs like 1.00 something. When you're talking about millions of them, the average number is going to come out to 27.9769 AMUs. The silicon 29 came out to be 28.9765 atomic mass units. And the silicon 30, it came up to be 29.9737 atomic mass unit, right? So how do we get to this number once more? What we're gonna do, we're gonna take the percentage and we're gonna change it into a decimal. So this is gonna be 0.9221. This is gonna be 0.0469. And this is gonna be 0.0305. And what we're going to do, we're going to multiply that percentage now as a decimal by the atomic mass unit of the isotope. And we're going to add all of them together. When you do that, that's going to give you that number. So that's how we find the atomic weight, also called the atomic mass. So the atomic weight or the atomic mass are found by using the masses of each isotope combined together based on the percent which we find on nature. So that's how you do that number like that. Convert the percentage to a decimal, multiply by the mass of the isotope, take the other isotopic percentage and multiply by respective mass, and then combine all together, just add it together at the end, and that should give you the number that you see on the periodic table. So make sure you review that here and on the tutorial videos and work on that problem. Once you finish that problem, you can say that you understand how to find the atomic mass using the percent of natural abundance of the different isotopes with their respective masses. And once you do that, we are done with chapter 4. So real quick, we understand that everything is made out of atoms. You watch the video from Thomson and Rutherford and you understand how we got to that theory. Then we talk about the charges and mass of the electrons, neutrons, and protons. We told you that the protons and neutrons are located on the nucleus. I gave you an idea of how powerful that energy that holds the nucleus together is, how big it is, how much space is between, and all the fabulous things that we learn about our reality being kind of a perception that our brain takes from those proportions. Then we talk about how to write find the symbol of an element on the periodic table, knowing that the atomic number on the periodic table is the same as the number of protons, and that the number of protons has to be the same as the number of electrons, unless we're talking about an ion. And a cation would be one that is lacking electrons, so more protons than electrons, which is going to be positive. And an ion is going to be one that has more electrons than protons, which is going to be negative. Then we saw how we took a tour of the periodic table and we classified the periodic table by metals or non-metals, by the different family groups, halogens, alkali metals, and so on. And we also saw that the periodic table is divided by periods and columns, which are the groups, which are the rows and the groups, respectively. And we saw how to determine the charge of the ion. Based on the ion, you can go back and determine the protons and electrons. Then we move into the isotopes, which are the same element but with different amount of neutrons. And we saw how to write the isotopic symbol and how to go from the isotopic symbols to the protons and the neutrons. And then we saw at the end how we get the last number on the periodic table that we didn't know where it was coming from, which was the atomic mass or the atomic weight, which is nothing more than adding all the masses of the isotope based on the percent abundance of each one of them. And with that, we close chapter 4, which gives us the foundation we need to move into chapter 5 and most likely begin making compounds. So until the next one, see you soon. Take care.